Welcome to Super Students class. I, L. Kalpana, studying 10th standard. I am from TTWREIS Girls, Hanmakonda. First of all, observe all the things around you like books, chairs, windows, doors, everything. These are the things which we see in our day-to-day life and also which we use for our needs. But have you got a doubt how all these things are made up of? How they formed like that? What will be there inside that? Yes, if you get that doubt, there is a lot of information to know. To know that, let's discuss about a very important topic, that is atom and atomic structure. Before entering into our topic, let's discuss the objectives of our today's class. By the end of this session, you will come to know what is atom, matter, molecules and its types, subatomic particles, quantum numbers and electronic configuration. So let me start with atom. Atom means it is a building block of matter, means it is a basic point of matter. To prepare matter, the atom is the basic point. But what is this matter? Matter means anything which occupies space and have mass. For example, take a book. The book will occupy some space and it will have some mass, whether 10 grams, 20 grams or even 1 kg. But it is occupying some space and it will have some mass. So, which are these things which occupy space and have mass are called matter. And the things which we see around us, they are all considered under matter. But how this matter is formed? Yes, the matter is formed by molecules. Molecules means the combination of atoms and a group of molecules combined together to form matter. So we can say that a group of atoms combined together to form molecule and a group of molecules combined together to form matter. So the matter is made up of atoms and molecules. But do you think the all things will be same or will be similar? No, there will be some differentiations or variations or even types. Likewise, these molecules also have types. So let's discuss the types. So there are two types in the molecules. They are homoatomic molecules and heteroatomic molecules. What are these? Let's discuss them in detail. Firstly, homoatomic molecules. Homoatomic molecules means in this the atoms will be same. Means these molecules contains identical atoms. Those are called homoatomic molecules like nitrogen, chlorine, bromine, oxygen, like this. The elements which we see in the periodic table, they all comes under homoatomic molecules. And secondly, the next one, that is heteroatomic molecules. Heteroatomic molecules means these molecules contain different atoms. Means in these molecules there will be different atoms like water, carbon dioxide, ammonia, methane. Take water. It is the basic source of human life. This water is prepared by hydrogen and oxygen. Likewise, the carbon dioxide, the air which we exhale, it is the combination of carbon and oxygen. So this is heteroatomic molecules. So these are the two types of molecules which we see in our day-to-day lives and also which we use. So these are the two types of molecules. In the starting, I said atom, which is a basic point of matter. So while thinking anything, if you can we say that anything is made up of directly? No, it contains some particles. For example, take our body. Our body is one thing, but our body consists of many organs. Likewise, the atom is one thing, but it consists of some tiny particles inside it. That tiny particles are called subatomic particles. So what are these subatomic particles? There are 3 subatomic particles which are present in an atom. They are protons, electrons and neutrons. These are the 3 subatomic particles which are present in an atom. So let's discuss about these 3 subatomic particles in details. Firstly, protons. Protons are the positively charged subatomic particles which are present in the nucleus of an atom. And these protons were discovered by a great scientist named Goldstein in the year 1920. And second one, electrons. Electrons are the subatomic particles which are present in an atom. They have negative charge, means they charged negatively, and these electrons were discovered by another great scientist named J.J. Thomson in the year 1897. And the position of these electrons is they will always revolving around the nucleus in a circular path, that are electrons, and the mass of these electrons is equals to the 1 by 1836 of protons mass. And the third one is neutrons. Neutrons are the subatomic particles which are present in the nucleus of an atom, and they have no charge or they have zero charge, and these neutrons were discovered by a great scientist named James Chadwick in the year 1932, and the mass of these neutrons equals to the mass of the protons. So these are the three subatomic particles which are present in an atom, and in this protons, neutrons are present in the nucleus, and electrons will be revolving around the nucleus in a circular path. So these are the three subatomic particles. But have you got a doubt that in such a small atom these three subatomic particles are there, but how they are arranged? For example, take our class. Our class consists of students. They will be arranged in such a order where the teacher can see them properly. But these tiny particles, how they are arranged? Yes, to know that, let's discuss about the most important topic, that is structure of atom. And this structure of atom was proposed by many scientists, but what we are using today, that is Niels Bohr atomic model. Niels Bohr atomic model. This atomic model was proposed by a great scientist named Niels Bohr, and this atomic named as Niels Bohr atomic model. He proposed that the protons and neutrons are present in the nucleus of an atom, and the electrons will be revolving in a circular path. That circular path was named as shells by this Niels Bohr. So these are the shells. In this the electrons will be revolving, and he named these shells are K, L, M, N and so on. So these are the shells, and their values will be 1, 2, 3, 4. So this is the atomic structure of Niels Bohr. But do any atomic structure was directly accepted? No. So there is another scientist named Sommerfeld. He modified the atomic structure of Niels Bohr, and he drawn some elliptical orbitals in the shells which was given by Niels Bohr. So he drawn some elliptical orbitals in the shells, and he named these elliptical orbitals as subshells. And this was proposed by great scientist Sommerfeld, and he named this modified atomic model as Bohr-Sommerfeld atomic model. So these are the two atomic models which we are using to represent or to know the atomic structure of an atom. While discussing about molecules, I said some elements like chlorine, oxygen, fluorine, carbon. These are called elements, but actually in terms how we can say that elements? Elements means the pure substance consists of same number of protons in their nucleus. Means while discussing about protons and neutrons, I said protons are present in the nucleus. So that protons count will be same in every nucleus of an atom in an element. So those are called elements. So these elements are which we see in the periodic table. There are 118 elements. But to represent these 118 elements, do we have some order? For example, take a classroom. In that there will be 40 students. That 40 students are represented on the basis of the rule numbers 1 to 40. Likewise, these elements are represented on the basis of atomic number. What is this atomic number? Atomic number means the number of protons or electrons present in an atom. For example, take helium. This is one of the element, and as we know that helium is in the second position or in a periodic table. But how it got the second place? See, the helium contains 2 protons or 2 electrons, 1 and 2. So its atomic number is 2. Likewise, the carbon, it contains 6 number of protons or 6 number of electrons. 1, 2, 3, 4, 5, 6. So its atomic number is 6. Likewise, the magnesium. Magnesium contains 12 number of protons or 12 number of electrons. So its atomic number is 12. So this is the way how we represent the elements by using their atomic number. But while discussing about protons, neutrons and electrons, I said the exact position of these protons and neutrons are the nucleus. These both are present in the nucleus. But the electrons are always revolving in the atom. But can we say its exact position? No. But we can say it is assumed position by using some numbers. So what are that numbers? Those are called quantum numbers. Quantum numbers means knowing or having the probability of electrons present in an atom is called quantum numbers. Mainly there are 4 quantum numbers. They are principal quantum number, angular momentum quantum number, magnetic quantum number and spin quantum number. These are the 4 quantum numbers which we know the probability of an electron. So let's discuss about these 4 electrons in detail. Firstly, principal quantum number. This is the Niels Bohr atomic model. This principal quantum number is the Niels Bohr atomic number. So in this he arranged the shells and he given the namings to that shells K, L, M, N. So in this principal quantum number it explains about the electrons or the shells. It explains about the shells and the size of the shells and the energy of the shells. So there is a size and the energy of these shells are 1, 2 and 3 and 4. So these are the energies of these principal quantum number of shells. So this principal quantum number was proposed by Niels Bohr and the principal quantum number is denoted with small n. This is principal quantum number. Nextly, the angular momentum quantum number or the azimuthal quantum number. This azimuthal quantum number is the Bohr-Sommerfeld atomic model. Means what? He drawn the elliptical orbitals in the shells. So this is the shells. These are the elliptical orbitals drawn by the Sommerfeld. In this angular momentum quantum number, it explains about the shape of the orbitals. Shape of the orbitals. And that orbitals are S, P, D, F and their values will be 0, 1, 2, 3. This angular quantum number was proposed by Sommerfeld and this angular quantum number is denoted with small l. And the third one, that is magnetic quantum number. So see, in this magnetic quantum number, it explains about the degenerative orbitals. Means the orbitals where they splitted in the presence of magnetic field. Those are given in the magnetic quantum numbers. For example, see this, it is the s orbital. Means the electrons in this will revolve in the spherical shape. And in the p orbital, the electrons will be moving in the dumbbell shape. And in d orbital, the electrons will be moving in the double dumbbell shape. And also in f orbital, the electrons will be moving in double dumbbell shape only. So this is the magnetic quantum number. This was proposed by Landé and the magnetic quantum number is denoted with ml. And finally, the fourth one, the spin quantum number. The spin quantum number means it explains about the spin of the electrons. Means in which movement the electrons are moving. That is given in this spin quantum number. The electrons will be moving in clockwise direction or anti-clockwise direction. See here, the electrons will be moving in clockwise direction or moving in anti-clockwise direction. So these are the spin of the electrons and the values of these clockwise and anti-clockwise direction will be plus 1 by 2 or minus 1 by 2. This spin quantum number was proposed by 2 scientists. They are Uhlenbeck and Gaudsmit. And the spin quantum number is represented by ms. So these are the 4 quantum numbers which helps in knowing the probability of electrons in an atom. But While saying about elements, I said they are arranged in the periodic table. But on what basis they are arranged in the periodic table? Let's discuss that. So, on the basis of electronic configuration, the elements are arranged in the periodic table. But what is this electronic configuration? Electronic configuration means systematic arrangement of electrons in an atom is called electronic configuration. It is denoted in the form NLX. Here, N gives the value of principal quantum number, L gives the value of angular momentum quantum number, and X gives the value of number of electrons present in an atom. So, in this way, we represent the electronic configuration. But to write the electronic configuration, there are some rules. For anything, there will be rules. If we follow that rules, then only the system may work properly. Likewise, if we follow these rules in the electronic configuration, then only we arrange the elements in a proper way. So, let's discuss that rules in a details. So, there are three rules. They are of Bohr's principle, Hund's rule, and Pauli's exclusion. So, these are the three rules to write electronic configuration. So, let's discuss about these three rules. Firstly, of Bohr's principle. Of Bohr's principle states that the electron always enters into the least energy shell, then only it moves to the higher energy shells. Take example us. We will start from the nursery and we will study step by step, we will increase classes, then only we will reach the highest class. Likewise, the electrons in this of Bohr's principle, he states that the electrons will be firstly enter into the least energy shell, then only they will be filled or they will be moved to the higher energy shells. This was stated in the of Bohr's principle. And in the molar chart, he given that see the figure like this. In this, the electrons are filled in such a way. They will be first starts from here and then moves here and then here. So, they will first enter into the least energy shell, then higher and then highest. Likewise, they will be moving in a order. So, this is of Bohr's principle. And then secondly, Hund's rule. In Hund's rule, it explains that every electron or every degenerative orbital, firstly they will fill, then only they will be paired. First they should fill, then only they should pair. So, this states in the Hund's rule. And finally, the Pauli's exclusion. In this Pauli's exclusion, that it states that any two electrons of an atom will not have the values of 4 quantum numbers will be same. Means the values of 4 quantum numbers of two electrons will be completely different. For example, an electron has principal quantum number, angular quantum number and magnetic quantum number same, but there will be difference in the spin quantum number. So, in Pauli's exclusion, it states that every two electrons of an atom will not have the 4 quantum numbers same. So, this states in the Pauli's exclusion. On the basis of this electronic configuration and these three rules, we will write the electronic configuration of any element, then only they will be arranged in a systematic order in the periodic table. Yes, now let me give the glance about my topic. Firstly, I started with atom. Atom is a building block of matter, and the matter is anything which occupies space and have mass is called matter. And in that matter, we can take everything which we see around us like books, chairs, windows and many. And this matter is made up of molecules, and the molecules are the combinations of atom, and a group of molecules combine together to form a matter. And there are two types in the molecules. They are homoatomic molecules and heteroatomic molecules. Homoatomic molecules means the molecules have similar atoms in them like nitrogen, oxygen, carbon and so many. And the heteroatomic molecules, in heteroatomic molecules the atoms will be different like water, carbon dioxide, ammonia and so many. And then we discussed about the subatomic particles which are present in the tiny atom. Those are subatomic particles. There are 3 subatomic particles. They are protons, electrons and neutrons. So, these are the 3 subatomic particles, and in that protons are positively charged present in the nucleus of an atom, and the electrons, they are negatively charged and they will be always revolving around the nucleus. And finally, the neutrons. Neutrons are the subatomic particles which have no charge, and these are also present in the nucleus. Here the protons and neutrons are present in the nucleus and the electrons will be revolving around the nucleus. Then we discussed about the atomic structure, which was given by Niels Bohr and also Sommerfeld. In Niels Bohr, it states the electrons will be revolving in the shells named KLMN, and he given the values of them as 1, 2, 3, 4. This states in the Niels Bohr atomic model, but Sommerfeld modified that model and given Bohr-Sommerfeld's atomic model. In that, in the shells, he drawn elliptical orbitals and named them as subshells, and they are indicated or denoted with SPDF, and their values are 0, 1, 2, 3. And then we discussed about the elements, which are pure substance containing same number of protons in their nucleus. Like we see in the periodic table, elements like carbon, oxygen, fluorine, chlorine, like many. And then we discussed about the atomic number, how in which way we represent the elements. Those are called atomic number, and this atomic number is given in the form of the number of protons and or electrons present in an atom, and this is atomic number. Then we entered into the topic, that is quantum numbers, which gives the probability of an electron, and there are 4 quantum numbers. They are principal quantum number, angular momentum quantum number, magnetic quantum number, and spin quantum number. In that, each quantum number explains about the probability of electron. And then we discussed about the electronic configuration, which is the systematic arrangement of an electron in the atom, and it is denoted in the form NLX. Here N gives the value of principal quantum number, L gives the value of angular momentum quantum number, and X gives the value of number of electrons present in it. For example, take 1s2, here 1 gives the value of number of shells, and S means the subshell, and 2 means the number of electrons present in the atom. And then we discussed the rules to write electronic configuration. There are 3 rules. They are Aufbau's principle, Hund's rule, and Pauli's exclusion. In Aufbau's principle, it states that the electron first enters into the least energy shell, then only it will be filled in the higher energy shells. In Hund's rule, it states that first the degenerating orbitals should be filled, then only they will be paired. And in the Pauli's exclusion, it explains that any 2 electrons of an atom will not have the values of 4 quantum numbers will be same. There will be difference. So on the basis of all these, we will write the electronic configuration of an element, and that elements are arranged in the periodic table in such a systematic way. So this is regarding my topic. So finally, I want to thank my guide teacher and my mentor, Miss Anusha ma'am, and our beloved principal ma'am, Vimala ma'am, and the friends and my teachers who supported me to do this project successfully, and the RC of our region, DS Venkana sir, and our beloved secretary sir, and the TSAT channel who given me this golden opportunity. Thank you each and everyone.